Okay, welcome to the video on the product and quotient rule. First of all, we'll start with the product rule. So we're going to let f and g be two separate functions that are differentiable at a point x. This means the product function, which is going to be fg, so the two multiplied together, is differentiable at x, and fg prime x equals f prime x g of x plus g prime x f of x. So, to explain what that means, we'll put it into a different form. So, the derivative of the two functions, f of x and g of x, with respect to x, is equal to the derivative of f of x with respect to x times by g of x, plus the derivative of g of x with respect to x times by f of x. And then this is the formula we can use to differentiate a product function. So let's show this with an example. If we say we want to differentiate x squared e to the x, what we're going to do first is identify the functions. So we've got f of x, we're going to call x squared, and g of x is going to be e to the x, and then we want to differentiate these. So d of f of x, df of x over dx is going to be 2x, and dg of x by dx is e to the x. So we've just got to put it into this function now. So the derivative of x squared e to the x by dx is equal to 2x lots of e to the x plus e to the x lots of x squared. And to simplify that, we can take out a factor of x e to the x, which leaves us with 2 plus x lots of x e to the x. And that is the derivative. Okay, so we can do another example. We're going to differentiate x plus 4 lots of 2x minus 9 using the product rule. So we're going to let f of x equal x plus 4, g of x equal 2x minus 9, df by dx is going to be 1, and dt by dx is going to be 2. So now we've just got to put it into the formula, which will be 1 lot of 2x minus 9 plus 2 lots of x plus 4, and is equal to the derivative of plus 4 2x minus 9 with respect to x. We can then simplify this down and get it as 2x minus 9 plus 2x plus 8, which is equal to 4x minus 1. That's the derivative using the product rule. Okay, so now we're moving on to the quotient rule. We're going to have f and g again, two functions which are differentiable at x, but this time g of x is not equal to 0. So the quotient f of x divided by g of x is differentiable at x, and the derivative of the quotient with respect to x is equal to the derivative of f of x with respect to x times by g of x minus the derivative of g of x with respect to x times by f of x all over g of x squared. And this now is what we call the quotient rule. So we're going to go on to an example now, and that example is going to be that we want that h of x, another function, is equal to x minus 1 divided by x plus 1, and we want to find dh by dx. So first of all, f of x is going to be x minus 1, with g of x being x plus 1, and then we want the derivatives of them, so df by dx is equal to 1, and dg by dx is also equal to 1. From there, we can put it into the formula. So dh by dx, where h is our quotient that we started off with here, is equal to 1 lot of x plus 1 minus 1 lot of x minus 1, all divided by x plus 1 squared. So we can simplify that out, so we've got x plus 1 minus x plus 1 all over x plus 1 squared. The positive and negative x's cancel, so we just get 2 over x plus 1 squared. And that is how you use the quotient rule. Okay, now it's your turn. So use the quotient rule to find the derivative of h of x, which is 3x divided by 2x minus 4. Pause the video now, and then restart it again when you're ready for the solution. Welcome back. Now, let's start off by setting our values of f of x and g of x. So f of x is 3x, g of x is 2x minus 4, and their derivatives are 3 and 2 respectively. Right, now just put it into the formula. So h dash of x is equal to 3 lots of 2x minus 4 minus 2 lots of 3x, all divided by 2x minus 4 squared. Expand the brackets, 6x minus 12 minus 6x, all divided by 2x minus 4 squared. We can cancel the positive and negative 6x's, so we get our answer as negative 12 over 2x minus 4 squared. I hope you've enjoyed the video on product and quotient rule. Thank you very much.